Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this couple of videos we are going to take a detour from pandas and talk about basic descriptive statistics. And the reason for this is that in coming videos, when we start using some of these statistical methods in the code, you'll be able to interpret what the output is, and you'll have an intuition about what's probably happening in the background when the code ran to give you that particular output. So here in this couple of videos, we're going to talk about all these topics that are put here on this slide, starting with what is population and sampling statistics, and then what is histogram, mean, standard deviation, all the way up to geometric mean and harmonic mean. So there's a lot of stuff in here, and I tried to make one video, but it was more than an hour. So I've broken that up into multiple videos, and in each of those videos you'll see parts of this being discussed. So I hope you learn from these videos. So let's get started. Now, based on that, we can go ahead and look at each of these uh, items, such as the mean. Now, if we are going to take a mean of the battery life data for 1000 laptops that we have collected, we could look at this particular distribution and see that the mean is 35. But how do you manually go ahead and calculate it? So to manually calculate the mean, let's say we are not going to use all the 1000 values, we'll just use 4 values for now: 11, 34, 55 and 40. So they are in minutes. If we sum them, the sum is 140, and if we divide this sum of 140 by 4, that's when we get the mean, which is 35 minutes. So this is an arithmetic mean, which is in the center in this data set, but it's not necessary that the mean is always in the center. But the takeaway from this particular slide is how to calculate mean and what a mean means. It's just totals of all the observations divided by the number of observations. Next, let's look at standard deviation. So as seen on the left hand side, here we see the curly braces. The first curly brace shows that the standard deviation space. So 0 is 0 standard deviation because it's at the mean, and then you have 1, 2 and 3. The sigma shows is a symbol for population standard deviation. I know that this is a sample of only 1000, so it should ideally be small s, but I've kept it as sigma in this particular figure. So that's one standard deviation. So when reading this, you can see that how many data points are within plus or minus one standard deviation from the mean. That's what we see here. Okay, and then similarly, how many data points are between plus and minus 2 standard deviations from the mean. So how do we calculate the standard deviation? Again, we are not going to use all 1000 data points, but we'll look at just 4 of them. And to calculate standard deviation, here we have the data points. We calculate the mean of those data points. In this case, it's 35. Then we take the difference between each observation and the mean. So 11 minus 35, and then take a square of that. So it's 576. When we do that for all the observations and take our sum, we get 1002. Now if you divide that sum by n minus 1, so number of observations minus 1, that will give you, and take the square root of that, that will give you the standard deviation. In this case, it is 18.27. Okay, the variance is similar to standard deviation. So standard deviation is square root of variance, right, that we saw in the previous video. So what variance does is it tells us the spread of the data. So how far apart does the minimum maximum go and how widely spread the data set is. In this case we see that the spread is from 5 to 65, and there is a lot of values in middle. So higher the variance, the more variability there is in the data set. That's what it tells. The more the observations are away from the mean of the data set. So to calculate variance, it's halfway step as we saw in the standard deviation. We take the mean of the samples or observations. So we have 11, 34, 55, 40, mean is 35, and then we take the difference between the observation and the mean, square that, and then add all that up. So 11 minus 35, square of that 576. We do that for all the observations and then take a sum of that. So that's 1002, and then we calculate the variance by dividing it by n minus 1. N is the number of observations. So here we have 4 observations, so n minus 1 is 3, and the variance after division we get it as 334. The reason why we divide by n minus 1 and not n is because we are dealing with sample data set and not the entire population. So to adjust the degrees of freedom, we need to subtract the number of observations by 1. That was it for this video. In next video, we'll continue this discussion on statistics and covariance. Please like, share and subscribe. Thank you.